And with that, I will hand it over to you, Stefan.
Thank you, Dixon. I have to say, I'm really impressed by the poll results today. It didn't quite match my expectations, and it's definitely useful to see what I can bring to our audience in terms of learning and discovering new tools. I'll just share everything that I have here. If you don't see the slides, let me know. All right, so data validation is definitely not the most popular subject to talk about. We had presentations, demos here in the community hour for model serving, for training, continuous training, a lot of things. This is probably not something that comes up often. In fact, there may be different definitions for what data validation even is. And I'll try to clarify that a bit here, at least the way that we see it at ZenML. Depending on who you ask, they will give you a different description of data validation. I like to think about it as being applied exploratory data analysis in a way, in the sense that it uses much of the same technologies that you would use during your proof of concept, while you're still training your, iteratively training your first model. The same type of technologies you'll see here, and maybe even the same tools, but a lot more, right? Because it's being applied to a production setting. It's being applied to an automated setting through pipelines, from ML pipelines, and so on. Usually, I mean, the simplest thing you can do with data validation is to profile your data and to visualize those profiles. But it gets better because data validation tools allow you to write automated testing that you apply not only for your data, but also for models. And you'll see that Deepchecks has an extensive library of tests that you can also use to ensure the quality, not just for your data, but also your models. Ultimately, yes, that's what data validation is: quality assurance for the entirety of your machine learning project. And yeah, it's not a lot of fun because testing, I mean, who wants to do testing, right? It's coding is fun, testing is usually something left aside. But as I'll show you today, these tools that ZenML integrates with are easy to work with. ZenML makes it really simple to extend your machine learning pipelines with functionality from the very beginning. Which brings me to when you should use data validation in your machine learning pipelines. I would say start right away, early on, and then do it all the time, everywhere. As I said, you can start right away by just logging data profiles for all the data that is ingested, that is circulated through your machine learning pipelines. And it's really easy to do, and I'll show you in the demo section. The next thing that you can do, once you start logging your data profiles, you can add steps in your pipelines that check the integrity of the data that is ingested in your pipelines, especially important for new data. And data integrity basically means things like, check that your values are set, you don't have null values, or you're not missing any labels, your categorical data fields. So categorical features are not inconsistent throughout your data, and so on. And you can do this everywhere. You can do this with data that's coming in for the training of your model, test data that you use for the evaluation of the model, and even during inference. New data arrives for inference every time you can collect it. You can apply these tools to it and collect these profiles, or even test it for things like drift. And of course, there are many kinds of drift. The thing that you can start using straight away is to compare the training data that you use for your model to the testing or the validation data that you use it, and avoid this thing that's called train test data skew, where you end up validating your model with data that doesn't really reflect the data that you use during training. and other things like data drift, concept drift. This is not a new thing. It's really known. It can damage your model in the long run, especially if you have continuous training or continuous deployment pipelines. This is where you would use data validation. And of course, I mentioned that it's not just data that you're testing with data validation, it's also models. We currently only have one tool in our set of integrations, that's Deepcheck, that is able to do this. And you do this, for instance, to compare the same model, how the same model performs between new versus reference data, or even do model comparison on the same data. This is a simple use case of a training pipeline where you could insert basically steps to help you with data validation. Even if you're not actively looking at these, the fact that you're collecting the information that is produced by these steps will help you later on maybe to go back and look at the history of how your data evolves in time. And who knows, they might be even provide some key insights into why your model started degrading recently and so on. This is a batch inference pipeline use case. Data validation also plays an important role in inference. You can do the same thing with data that comes in and you're using it for batch inference or even for online inference. You can collect it, you can check that it's still valid, it's still high quality data, it respects the integrity expectations that you set out. You can compare it against reference data to avoid drift affecting your model and maybe detect that and trigger a continuous training pipeline that you may have somewhere in your project. A lot of useful places where you can use data validation. It can get a lot more complicated though. So this is a continuous deployment pipeline. I just wanted to show you that all of these boxes, they fit in everywhere. I'm not going to go through this step by step, but just so you know, it can get complicated, and not in the sense that it's difficult to set up, but in the sense that data validation can play roles everywhere in your pipeline. You can use data validation tools to detect and model concept drift, for instance, or to perform model performance comparison. This pipeline in particular basically loads a reference data and a current model or reference model that has been trained previously, and you can use that to train to compare it against a newly trained model, take some decisions, and based on those decisions, you can trigger a deployment in production or not. Say you don't have the necessary performance criteria met. How do you use this with your ZenML pipelines? Well, we have 4 integrations to date. Great Expectations is one that you've probably seen in a previous community hour. Deepchecks, evidently, and ylogs. Some of these evidently and ylogs in particular have been featured in ZenML for a while. Deepchecks is quite new, and it's basically the star of the show today. All of these integrations come equipped with built-in pipeline steps. They all have sensible defaults, so you can just plug them into your existing pipelines anywhere you deal with data or models and get running straight away. Of course, there are visualizers everywhere because data validation wouldn't be as fun without the ability to visualize these results, data profiles, drift results, and so on. And we'll hopefully see a lot of that today. All right, so how do you actually use it is part of my demo today, and I'm going to switch to that. I have set up some things in advance because this is taking a lot of time to set up and so on. I have a Deepchecks. This is basically our example, an example that's featured in ZenML with Deepchecks and a data set that is called the steel plates dataset. It does a lot of things. I'll just trigger it and run this pipeline in the background, and it will open a lot of things. as it's running through the pipeline and it's loading visualizers for the thing that it stores in the artifact store. And in the meantime, I want to show you what that pipeline looks like in our new and shiny UI. Data validation pipeline. Let's take a run here. Okay, let's see if I can make this a bit bigger. This is a really simple pipeline, not nearly as complex as the one that I showed you at the end of the slides. It's just a data loader, and it loads data, it splits it into two, training and evaluation. It trains the model, and then it evaluates the model. These are the 3 steps on the right. Aside from these steps, you can see these other steps that are basically inserted everywhere in my pipeline. All of these steps are Deepchecks steps, and they each perform a function that is useful for data validation. For example, the data validator step here, and we'll see the results of that in soon, I hope. Nope. Again, is a step that looks at the input data for training and runs some data integration, data integrity checks. Then the data drift detector, what it does is it compares the training data to the evaluation data, and it will try to detect things in that do not match between the two sets. And then, of course, there are some additional steps in here that are specific to Deepchecks and only provide functionality that comes with the Deepcheck. Model validator, this guy is basically running some sensible defaults that looks at your model, and for instance, it will. I'll be honest with you, I don't know all of these data validation functionality steps that come from Deepchecks because they are so not working. They are so very up to date with new technologies, and I have a tough time keeping up with those myself. Let's see how I can fix that here. Things never work when you run them in a live demo.
However, they do give the opportunity to see how you debug them. So I suppose you just like reset the local stores, and I now just have to recreate the stack.
All right, register stack, local Deepchecks. All right, register.
Maybe you should set the stack to be active.
Thank you. Okay, that was hopefully just a couple of minutes detour on my part. Yeah. And we should see these results in briefly. All right, so this pipeline will open up 4 checks, 4 check results that were executed with Deepchecks. And I would like to take just a few minutes to walk you through these because these are really interesting. First of all, like I said, all of these integrations provide you with sensible defaults. Not all of these defaults will work with any data sets. You have to actively go in there and fix some of the configuration parameters for them. For instance, this particular step check failed. I'm using the iris dataset here. It failed because this particular label, petal width, has a predictive power that is too high, and it could just basically predict all the labels by itself. This is something that is included in this check that comes from Deepchecks. It basically detects, I don't know if that's a thing with this data set or not. I just wanted to show you this. Of course, there are many other tests that are included here that have passed. This is just a data integrity check. So it doesn't really look at different data sets. It just looks at one data set and detects things like missing labels, nulls, conflicting labels, and so on and so forth. So really, really nice from the Deepchecks developers that they basically pack these all in, and you don't have to do a lot of coding to add this to your pipeline. In fact, the simplest thing that you can do is to do something like this. This is how you define load, rather, a step from our built-in library, and then you insert it in any of your pipelines, as simple as just adding it to ingest the data of your choice. There are 3 more results here. This is a model validator. This takes in a model, and what it does is, it's not a lot of tests here, obviously. Not a lot of things you can do with a single model. It can measure the inference time for the model and other things. Like I said, I don't really have an explanation for all of these nice built-in checks. You can check them yourself. Look at the Deepchecks documentation. A drift detector is something that you are perhaps more familiarized with. Again, this label correlation will show. This is comparing 2 data sets, the train and test data sets. And there are some inconsistencies that have been detected, which point to something like a train test skew with your setup. This is something that can be picked up in an additional step, and measures can be taken. Right now, the step isn't configured to basically interrupt the training pipeline. It just collects all this data that you can visualize later on. And finally, model drift detector. This test compares the performance of the model between the train and the test data sets. A lot of data here as well. And all of these reports are, of course, tracked, versioned. They are stored in the artifact store that is configured with ZenML. You can go back in time, you can retrieve them, you can compare them. Even if you're not actively using the data validation in your initial project, I highly recommend that you start doing something with it, even if it's just collecting data profiles, that things you can do with Evidently, which unfortunately I don't have time to show you today. But yeah, you should definitely start using this. Take a look at all these very useful data that will give you insights in how your model is performing, not just now, but months later when you are in production. I hope you had fun, minus the minor inconvenience of me botching the presentation a bit in the middle. I'm curious if you have any questions. I'm here to answer them.